Comrades, gentlemen and ladies, we shall now move to the second phase of the conference by Chinese Society of Integrative Medicine, Permanent Member of Council, Chinese Society for Integrative Medicine, Burns Specialty Committee, Honorary Chairman, Editor-in-Chief, China Burns and Wounds Journal, Professor Rongsheng Su, of Human Regeneration and Restoration Science, teaching us all. He spoke on the topic, Human Regenerative Life. Let's all give a big round of applause. Welcome. Dear old and new friends, how about this morning? Let's take an hour or so, to all of you again, report our study of burn wounds from. It has evolved to the present, this process of regenerating the human life science system. During this period, attention everyone, whether it's a foreign friend, still a friend of China, pay attention to each program on the slide. That's how we know the core of what we're going to talk about today. Today's talk, that's a first, in public places, to announce the birth of this science. On September 16th of last year, we just report a scientific profile. This time, we're reporting on the results of the application. Our topic is human regenerative life. It's a new word. In other words, conceptually, everyone is refreshed. Scientifically, it's an original innovation. And the result of this application of human regenerative life, it's from our science of human regeneration and restoration. This scientific system was born in China in 2009, starting now at the University of Southern California, USA. It has been specifically established. Academy of Applied Human Regeneration Science. Global recruitment for masters and PhDs starts this year. In fostering the science of human regeneration and resilience. Highly sophisticated world talents and worldwide carrying out this scientific advancement of regenerative life. Let all people enjoy regenerative life as soon as possible. This is the first concept we give. Know the term human regenerative life. And that's what we're going to do with our main presentation today. Up until that point, we all need to confirm and understand how long is human life? Whether Chinese or foreign or somewhere else. People are trying to think, how long is human life? Up until that point, there's no one right and a more scientific understanding, just on the telomere doctrine, with a more recognized concept. That's 2011. 3 scientists who discovered telomeres win Nobel Prize. This symbolizes a consensus. That's for the telomeres themselves. It's just a recorder of life. For every year of human life, the telomeres are smaller, so to speak. When people live to be 80 or 90 years old, the telomeres are a third smaller, so there's still 2/3 of life left to enjoy. That's the consensus. But then, with this consensus, how to make human life longer, it's what all scientists strive for, but so far, not yet present in the results. That's what we're announcing today. Mabel Shoda, what's going on? Must achieve twice its lifespan without aging, in order to achieve 3 times the life expectancy of modern man. That's a 100-year lifespan. Do everything you can to slow it down to 300 years. There was a consensus on this line of reasoning. But what happened? Actually, not yet. Then it's now. Results of scientific experiments on Mabel's rats. What's the result of this? With nutrients that initiate the regeneration of life. Feeding male rats, not aging at twice the age, realizing the control group died of old age at 100. The reason why? This is the first science and its corollaries. A consistent result was achieved. Well, we've got people twice our age who haven't used it yet. That's what we humans live for. How we live without injustice. Today we open the secret, because the results of our human applications, the results of the 5-year period have been completed. Younger today, 5 years later, than I was 5 years ago. Wait a while to see in person is an example of watching the series of. Then look at regenerative life. First of all, where did the concept of regenerative life come from? How to confirm the concept? We all know that. Human development from embryo to adult, from birth to death, a process that everyone knows is human life. But this time of life, it's only 80 or 90 years. Then we take this life. It's called the primordial life of man. But now it turns out, in the course of this primitive life, every program leaves a life. We call it potential regenerative life. In that case, we need to take this potential regenerative life now, put it into words. Let all men enjoy this regenerative life. This is the concept of regenerative life. That is, humans have 2 lives. You remember, one life is our original life. One life is our regenerative life. Where the hell is that regenerative life? That's what we all care about. It's not an empty promise. Let's start with a mechanism. We call regenerative life cells PRCs, also known as potentially regenerative cells, the concept of potentially regenerative cells. So where did this cell come from? First of all, we know the primordial life of the human body is derived from the oocyte, development of stem cells from oocytes, and then from the stem cells a human body is formed. So it's from this cell. But this cell, it developed into 60 trillion cells. It becomes a human body. It has evolved as a process of changing 2. That makes 2. But the 2 continue to proliferate and differentiate and should be out of 4. It came out 4. But of the 4, one of them is the regenerative life we're talking about. According to this law, these 4 should be 8 long. But 4 didn't make 8, only 6. So that one didn't develop again. It's staying. This cell stays until the person dies. In 1984, Many scientists published articles about. There is a class of cells in the human body. From birth, it didn't grow until one's death. I don't see any function in this cell. So from our research on burn regeneration, where does the regeneration of burned skin come from? It comes from this cell. I'll tell you more later. That's why it's important to leave every program. As long as the telomeres are in, life is in. This regenerative life exists. So to speak, the next 200 years of mankind depend on it. It's a concept. This creates the notion that there are two lives inside the human body. A life is a regenerative life. A life is an original life. It's responsible to say that this was announced today. We have basic research information from various confirmation of every procedure in the human body. Confirm this cell. It's in every tissue of the body. It's just that humans don't wake it up. It's not waking it up. It's not nurturing it. So this is the cell that regenerates life. Sources of living body sources. Where was this source first discovered? I was just talking about coming up from the burns. But how do you prove it? As you can see, this is in vitro confirmation of it. It's the separation of the adult tissue cells of the human body. And then we use the activation method. Put it in this culture. I saw some tissue cells right away. It becomes this stem cell. In that case, what is the name of this cell that starts to turn into a stem cell? It's called a PRC cell. Potential regenerative cell. It's visible and tangible. This cell is the stem cell's mother. Stem cells have two moms. A mom is a primitive egg embryo cell. A mom is our potential regenerative cell. Without doubt, the original cells were programmed through each. It's had two children. Everyone saw it. Two procedures. It's the body's life mechanism. See, in this mechanism, we have access to potentially regenerative cells in vitro. That is, you can get stem cells. Learn more about what the function of this potential regenerative cell is. Remember, it's easy. Just remember the features. Our burns, wounds, broken fingers, regenerative organ recovery. Everything is solved. Everything is solved. This potential regenerative cell, in the presence of regenerative nutrient activators, it becomes a stem cell, inside and out. With stem cells, become all stem cells. They all have it. It can become any body cell, into any organization. From any stem cell to any tissue. This forms its functional system. We're in the body now. They all have this potential life cell. Whether it's an organ or a tissue, just activate it, and then cultivate it. The body renews itself. Change one's address, etc. Ensure the health of all organs. And how long does this cell live? It's the same as telomeres. One more thing we all know. That's when this cell was first discovered. See 1984. Unlike that, we're in the middle of a burn study. Experimentation with animal testing methods. Regenerative wetting therapy was found on this trauma. Its cells are not the same as those that don't regenerate. As you can see, this is more cellular. None of the histocytologists at the time recognized what this cell was. We've been saving it for how we're going to prove that it's a human regenerative cell. 5 years of waiting on science. Finally. Wait for what? Wait until American and Polish scientists taking the human body from the earliest cells of the skin embryo. After the establishment of the marking method, we'll use that to prove that this cell is the progenitor cell of the skin. So, introduce that method. Started in 1992. This is the research that was done. This research study is saying that all markers of the earliest cells of that skin from a human skin embryo to mark us as regenerating cells. What is this mark? It's a keratin 19 marker positive cell. See below. These are keratin 19 positive cells. After this confirmation, all at once the principle that we can regenerate skin if we don't have any. It's all open. But then it's just a stem cell. Express stem cells. It takes skin without skin, turning into a skin. Where the hell did it come from? It's a stem cell. It didn't come out of nowhere. Who's his mom? So this finds. We're looking at this tissue cell on the left. This tissue cell. In the tissue cells, you can see there's no skin tissue here. No skin tissue. It's all fatty spacer tissue. It's the cells inside the fat spaces turned into keratin 19 stem cells. In other words, this tissue cell. That's the PRC we're talking about today. As you can see, with this tissue cell, into keratin 19 stem cells, and then the organization. Organ of the skin. That's from nothing. This skin organ is not an epithelial cell. Gotta figure it out. It's a subcutaneous tissue cell. We later show that not only subcutaneous tissue can be changed, bone marrow cells can still change all the structures of the skin and subcutaneous tissue. This realizes in situ regeneration of skin organs. The skin is the largest organ in the body. The skin regenerated. Every organ in the body is renewable. Let's remember, it's a way for mankind to unravel the mystery of human regeneration. The first scientific experiment, and this science experiment, whether copyright or patent, the international ones are protected. That's why in situ cellular regeneration of organs, accomplished through a stem cell program. All these procedures, we invented regenerative technology. This result is out. We must use science to validate the repetition. Is the method that returns the validation, to verify the existence of this cell. So we immediately use this method to validate an intestinal mucosa. Use of intestinal tissues instead of embryonic cells. Remove the intestinal tissue. Remove the cells. Acquisition of tissue cells. And then this tissue cell. It's not stem cells. We need to activate it. Regeneration activation. After you activate it, and what does it become? Stem cells. Process of change. It's from the tissue cells inside. It's also known as a potential regenerative cell. Inside that tissue cell, and this stem cell becomes tissue. It continues to develop into an organization, and then this tissue ends up as an organ. It's the first human organ clone from tissue cells in vitro, and the only one. So far the world has not. It's all a concept. So this clone of an intestinal mucosal organ, realization of a program for human in situ cloning, that is, by in vitro cloning, confirmation of the in situ regeneration program. It also proves the power of the potential regenerative cells. This is an experimental model, or this one intestinal cell. Look at it in the longitudinal plane. That's the other side of the coin. This potential regenerative cell, it's obvious to everyone. Start cloning, and then it cloned a different organization, because it's an intestinal mucosa. There are 4 types of organizations. It's still cloning 4 organizations. These 4 organizations are then put together. You see it bonded together. It's a circle. This circle is the most basic tissue organ of the intestinal mucosa, and then this circle to this 5th figure. It becomes the fluff of intestines, then this structure and the internationally recognized, the solid structure of this intestinal mucosa of the animal. It's exactly the same, but we're living in vitro clones. The ones used internationally are from rat embryos. Technically, there's a huge difference. In 2001, when I did this presentation in Hawaii, our delegates at the conference at the time were excited to say, for the first time, we saw humans in vitro, cloning organs from tissue cells. I'm a live one, so to speak. Everyone should be happy to see this result. What's the point of being happy? Any tissue of the human body that is happy, all can be regenerated in situ. Now we see the gut. Wait till you see how the human body's aging intestines turn into a young stomach and intestines. The human body has realized this is the concept of the potential regenerative cell. And one more, let's look at our clinical evidence. We're all verified experts here today. Those of us with extensive burns. How did it come about? It's through the hands of all of us. We use our Mabel to regenerate the skin. Mabel is epithelial tissue, and regenerative activators of body surface tissues, and regenerative nutrients. Of course, there are many more potential cells throughout our body. Then let's say that according to the cellular classification of the egg embryo, more than 200 types of cells have its potential to regenerate the life of a cell. Another look at the soft tissue. That's what our experts here have accomplished. A soft tissue defect. How to become a fully resilient organization. What does it rely on for this function? It's all about regenerating cells. Why isn't this in the history books? It's just not historically activated and not nurturing it. These clinical cases are from the hands of all of you. The other bone, the facial bone, is burned. It's missing. The meninges are almost identical. Under this defect, we know that any surgical technique nowadays, there's no way to restore it. But the way we regenerate, I restored it to its original position. So telling this example we all know. But what's the reason? In the case of the PRC cells that we just talked about, they turned into stem cells to any tissue cell. Knowing this one law, our meeting today is a success. Look at the broken finger again. The end of the human body is an index that represents all the tissues and functions of the human body. If you regenerate a broken finger, humans have achieved organ regeneration. Who said that? I didn't say that. 2007. Scientific journals comprise 250 scientists to conduct a science PR seminar. One of the questions, it's how to regenerate a limb. If an amputated finger is regenerated, the world of life sciences realized. I had my secretary send an email back immediately. I said your eyes are on your side. Not looking at China. Not looking at patents. You've already realized this idea. You're meeting here a little too much out of touch with the world. So this broken finger regenerates. As you can see, it's not a simple thing. Not only do we regenerate broken fingers, and we're on the new regenerated severed finger, it can still be amputated and regenerated. What does that mean? Describe the regenerative life sustained by human. Not like the first life. He died in his 80s or 90s. This regenerative life is only possible as long as the telomeres are in. It's right there. See this broken finger? This is a doctor from our hospital. The ones who are here have come to the meeting as well. He treated it himself. Just a dab of burn cream. Mabel just wiped his fingers out. Why? It's simple. Activated regenerative life cells. The regenerative life cells have repaired it. This cell is not a keratin 19. It's all the tissue cells. That's the idea. And look at this secondary broken finger. This is the treatment I came for myself. This is a minister. For work-related reasons, I accidentally pinched my finger off. After you clip it off, the central government attaches great importance to. We've mobilized our medical microsurgery specialists. It's not going to work after this finger is attached. Said it was necrotic by day 6. When it's dead, we'll take it off and take a look. What is it? Infected and infused. And then we used our skills. Healing from the inside out simultaneously. This one works inside and out. Internal regenerative substances. Recycled material on the outside. So 11 days. It's so long when you see it. It broke under that fingernail. 22 days of growth. It's healing. The epithelial cells are covering. But at this point, the finger is still crippled. So what to do? I was nervous. Reported to higher authorities. I said I'd ask him to cut it again. So it's all agreed upon. Re-amputation of limbs. Or you're a cripple. Let's give him a new cut. From the nail bed to the body of the finger, You have to amputate once. Beyond this point, the wound is then transformed from an infected wound, turned into a fresh regenerative wound, and then it continues to regenerate. It's growing. I made up for the missing piece. Why did you add it? Let's see how easy this turns out to be. But it must be understood. Then let's say the new limb on still have regenerative potential cells. That is to say, the existence of cells with regenerative potentials. It's connected to life. It's not about having another one and not having another one. So let's all be happy. We're still alive. Wait until the no regeneration people are gone. We're still living like this. This is going to activate the regenerative life. The regeneration of this finger body. It's the secret of the body's entire regeneration. Bone regeneration. Look at his bones. 6 months. Start with that short and grow. The final restoration was in the form of a terminal phalanx. It's still growing because the human body has the ability to self-reproduce. It's just that it's not growing properly for various reasons. This one, if not for his fiber surgery, destroy the bone marrow cavity. That is, fingers like the ones our doctors treat down there. The length quickly reaches, but the bone marrow cleared him. It grows slower, but it's all grown. This description, regenerative life, whether pre-existing, still present in the new tissues and organs that will be regenerated in the future. His longevity and existence, it comes with the existence of his telomeres. Look down here. These fingers, this is what our doctor did. 4 burns to buy a finger. It's priceless, but such burns on the extremities, that's all it takes to grow this finger. Secondly, let's talk about the concept of returning to childhood, the concept of being young, because in the days leading up to my arrival, 21st, 23rd, 24th, director of the Anti-Aging Institute at the University of Southern California, USA. Old and new deans come to Beijing. We're in full communication. Post-exchange, I say establish the concept. I mean, isn't it true that in China we call it returning a child and it's considered returning a child? Rejuvenation would be more appropriate. People will understand that it's because they're young, not the one who's still a child. So how does this return of the child work? I'm going to crack the secret today. 2. What's the secret hack we're using? It's utilizing a model of fibrosis in our body. Models of human fibrosis. What's the relationship with returning child? That depends on what kind of relationship we have with aging backwards again. Human aging. It's the body's cells that renew themselves 50 or 60 times. No more updates. It becomes a fiber cell. People age. It's such a simple mechanism. So what are we still children? How to replace senescent cells with regenerated cells in situ to it. Then the organ doesn't age. The organs are rejuvenated. It's that simple. It's a concept of returning children.